Hi, and welcome to OSPF Chapter 5. Now you might be saying, welcome to OSPF. We already know OSPF. We learned it in the last class. That is true, and I'm going to assume that you still remember most of that. But we are still going to practice it because I know it goes away. But OSPF should be pretty much in your wheelhouse right now, setting up a basic network in OSPF and making the run and using the show commands to verify that it's working. Should be going on, but there are several aspects to OSPF that we haven't looked at yet. So I'm going to do like a 4-slide review and then introduce a couple of terms in the first part of this lecture series, and then in the second part we'll talk more specifically about what we'll be doing in this chapter. So I shall go away and you shall be treated to a basic review of routing versus switching. We already know, now we've been studying switching and we've been looking at how to manage switches and how to scale networks and make them bigger, but sometimes networks have routers within them. And so the routers can also be part of an internal LAN. They don't always go between networks. They can be managing traffic inside of a network. So we have So when we need that layer 3 routing and switching working together in the core layer, we get to non-broadcast multi-access. But remember, we have static and default routing. So static routing is for small networks and hubs, or stubs, I should say. A stub where it just goes one way and back. So we don't configure static in here. Well, we make a few static routes, but not very many. And then default routing lets networks scale when you anticipate growth. And so as you recall, configuring OSPF, there's just a brief look at it. You know this. And then also there's OSPF version 3 that when we can using IPv6 and the IPv6 commands. There'll be some, might be a little dust when it comes to version 3, but you'll get it back quick enough, I'm sure. And then we show IP OSPF neighbor and show IPv6 protocols, as we do for all our protocols, to see what we're running. Now, the network types inside of OSPF, we can have point-to-point networks, which are just two routers on one link, each end of a link. Broadcast multi-access means you have a lot of routers in an Ethernet network that are interconnected, and they might be connected in a loop, etc., and which isn't a problem like it is for switches because they don't flood broadcasts, but they still need to work together within there so that they know how to share data. And then there's NBMA, non-broadcast multi-access networks, where you have a lot of routers inside of a network and they don't broadcast at all, like a frame relay type switch. And frame relay is kind of outdated, but that's an example of an NBMA router or network. And then point-to-multipoint, where you have one router talking to several routers at one time. And it's kind of a hub-and-spoke technology. Sub-interfaces come into play here. And you need to route among the sub-interfaces even. And then there's a special virtual link. Virtual links and virtual routing are becoming even more and more important. But we'll just touch on that today. That most of virtual routing is beyond the scope of the course. Now when we get into multi-access networks, we have the problem of creating multiple adjacencies with all kinds of routers through the switch. And it's not just the point-to-point adjacencies that we've been looking at so far. Remember, the link state advertisements come out making OSPF work when they initialize, and they're trying to exchange networks, but it could be, LSAs would get pushed out all over the place as well. So we have to manage how OSPF, or optimize it anyway, optimize OSPF traffic in a multi-adjacency topology. Okay, so how many adjacencies do we need? Well, there's a little formula here to articulate that. But the main idea is somebody's got to be the boss of all these routers. So we do that by choosing a designated router, the OSPF DR, and then the BDRs are the backup designated routers. And so what happens here is all of the BDRs only exchange LSAs with the designated router, and this manages traffic, keeping the LSAs, the every 2 seconds, the updates and commands. That way, only one router, the designated router, is deciding the topology and how the broadcast and network traffic should be managed. So it tells who's up and who's not, what's working, what's not, because every router is only exchanging with one router instead of all the routers, thus managing the traffic. So here's just a quick rundown of the bullets. The DR keeps adjacencies and flooding off the network, and the BDR is elected in case the DR fails, the BDR comes up. And so all other non-DR and BDR routers become DR others. Looks like the word druthers, but it's designated router, other router. And they only form adjacencies with the DR and BDR. Now, let me come back here. You notice that we have a BDR, just one BDR, and then 3 DR others in this one here. So the DR and the BDR are receiving the same kind of updates on both sides. And the BDR is ready to go, but only kicks in if the DR fails, and then they'll have another election. And there is a whole process to this election that we'll talk about. So only the BDR and DR are getting LSA traffic. And if you have 50 routers, that can add up to quite a bit of traffic. And OSPF has its own multicast address. And you'll notice this, and you'll see this IP address from sometimes, all right? So the LSAs to the DR and BDR are 224.0.0.6, and the DR multicast at 224.0.0.5. I've seen that on a couple of CCNA cert exams. So if you can understand the 224.0.0.5 and 0.0.6 are reserved OSPF multicast addresses, that just might get you a point or two on your way to your certification. So the DR and BDR are only necessary on multi-access networks. On a regular network, you have to have your link state adjacency. So it's only when you have several routers inside of a LAN environment. Okay. So verifying DR and BDR, show IP OSPF interface, and then the interface number. All right. And so this command here, So this command here, show IP OSPF interface, all right, and then gigabit Ethernet 0. That takes us into this where we can see the designated router, the ID, and the router ID is something we'll be manipulating later on. And then the BDR 222, so it's picked on highest order, all right. And then it's adjacent, the neighbor count is 2, adjacent neighbors, etc. So all of these things get part of the background here. So you verify the adjacencies, and it'll tell you if it's a DR other, and if it's in full state, fully adjacent with DR or non-BDR, because the adjacency has to be adjacent in order for it to be a neighbor. Or right, it has to be fully adjacent. All right, and the differences here: full DR other, full DR, full BDR tell you which it is on each router, and if it's been all set up. And now if it's a two-way druther, then it's got a simple connection with a non-BDR DR. Now this is a lot of text here. We're not going to go through it all, but the election process you can pick out of the chapter. Highest interface priority is selected, and the second highest interface priority is the backup. And this is different than switching, where we went with the lowest cost became the priority. OSPF, it's a little bit reverse. All right, so you can configure the priority. All right, and if you make it 0, it'll never become a DR. So if you have a router that's just out there, you have other ideas for it, make it a 0. You don't have to worry about it becoming a DR. All right, and the router with the router highest ID is the DR, second high. And then if you want to have an ID, you can manually configure an ID if you want to make it higher than the IP address. So the highest loopback IP address you can just put in a loopback address and make it pretty high. That's an easy way to do it. Loopbacks don't have to be anything. But if there are no loopbacks, then you go to the active IPv4 address. Right? And in IPv6, it's a manual process. So, the DR-BDR election process that comes up, and if the DR fails, well, it has to be a reboot. It's not like spanning tree where if there's a change it updates. The DR and BDR are there, they're in place. They're not going to change until the DR fails, which usually means being taken offline. All right. For some reason it comes down. It doesn't have to be powered off. I mean, the connections can be cut too. And then the multi-access interface on the DR fails or is shut down, meaning taken down. And then the new BDR election will happen. So if you want to change your BDR, you can go in and change the priorities, but you still have to take the DR out and maybe the BDR out if you want to change who's who. So that's where I'm going to stop for this first portion and digest it and go ahead through the first part of the chapter, and I'll come back and talk about different ways we can manage OSPF that we've hinted at in the first part.